Algebra 2 skills number 12, quadratic formula. Quadratic formula here is a powerful tool that can be used to solve any quadratic equation, as we'll see. Here is the formula, which seems random positioning of A, B, and C, but it comes from completing the square on the standard form of a quadratic. So standard form of a quadratic would be where our variables are in descending order in terms of their exponents, and where I'm set equal to 0. So if I complete the square on that, which is a separate video, you're going to end up with this. Make sure you're set equal to 0 and realize it can be used with any quadratic equation, but first make sure you're in standard form, or A, B, and C would not be properly defined. So for our first example, we have a simple quadratic equation here. We're in standard form, we're set equal to 0. So we'll color code here, A being the coefficient here, B being the coefficient here, and C being the constant. So we're going to color code the quadratic formula and put those numbers in. So notice several things here. I put parentheses around this B, which is particularly important if B is negative. B is not negative here, but I did put the parentheses. That's just a good habit to get into. I've seen many mistakes on folks having a negative B and not enclosing that in parentheses, and it messes you up. Also, whatever B is, it's going to be the opposite of B right here. So the common mistake is to get the sign incorrect here. Once you have it properly set up, most of your work is going to be in this part called the discriminant. So we just work on that radicand here. And if you do so, we arrive at our answer rather quickly. -9, 2 times 1 is 2. This inside ends up being 81 plus, because of the two negatives, 4 times 1 times 2, which is 8. 81 plus 8 is 89. And what's nice about this one is 89 cannot be resolved or simplified in any way. So we just leave it, and we're content to leave it exactly like this. Example 2, we're not in standard form. Let's subtract 5 so that we are in standard form. We're going to define our variables here and not worry so much about color coding this time. We're going to put it in the quadratic formula. Notice again these parentheses around that B value. Notice also that this B is negative, it's positive out here. A lot of 2's through there because of the A and the B both being 2, and we've got the 2 there anyway. But this one's going to be a little more difficult because though this is simple and 2 times 2 is 4, this inside here, 4 plus 4 times 2 times 5, this 4 plus 40 is 44. What's bad about that is it can be simplified a little bit, and it causes us a little more work. The square root of 44 can be simplified to 2 root 11, and what we have here are 3 numbers which are all divisible by the same thing, particularly these 3 numbers here. We don't worry about the 11, but 2, 2, and 2 obviously all divide by 2, so we go ahead and divide them all by 2. And this is our final answer. 2 divided by 2 is 1, which we would have to write that 1 because it does matter if you add or subtract from 1. However, both that 2 and that 2, which also divide to 1, are no longer necessary to write because it doesn't matter if I write a 1 here, it doesn't change anything. Also, it doesn't matter if I divide by 1. So 1 plus or minus the square root of 11. For a third example, again, we're in standard form. A quick tip, we're not in standard form, rather, we need to get it in standard form. But a quick tip here would be that we want A to be positive. Anytime we use the quadratic formula or factoring, it's just better if A is positive. That's the number in front of x squared. So I'm going to move these to the left instead of moving the 6x squared to the right. But this time, I'm not even going to tell you A, B, and C, or I'm not going to write it down. A is 6, B is -1, C is -7. I'll tell you, and then plug those in. Okay, notice again the parentheses around this B, very important. Notice again this sign is opposite of what it is here. That 1 and 12 is simple, but on the inside we have 1 times 1 is 1. Again, we have a negative and a negative. It's not always going to add like that, but often it does. 4 times 6 times 7, that's going to be 168, as you can see. 1 plus 168 is 169. But here we have another problem. Let's go to the next slide. The square root of 169, not only does it simplify, it's a perfect square. So it goes down to 13. Now, another mistake I see a lot here are folks that they'll keep that square root on there, even though they they evaluated the square root. If you take the square root of something and it's just a whole number, don't write the square root anymore. But at this point, the solutions are going to be 7, 6, and -1. You just keep that plus or minus. If you separate it, make it a plus here and a minus there, you see where those values come from. What we didn't put here in this video is an example of sometimes this will be negative and it makes an I come out here, which is perfectly fine. You just do it the same way and it's going to have an I on it. But that is the quadratic formula.